So hello everyone, in this video we'll be covering question 5 for our endsem. So first part of this question is distinguish between parametric versus non-parametric model and supervised versus unsupervised learning with examples. Now let's see. First is parametric versus non-parametric models. First, assume a specific functional form with a fixed number of parameters independent of dataset size. Example, linear regression, y equals to wx plus b. Logistic regression, naive Bayes. Advantages: it is simple, fast, need less data. Drawback may be too restrictive if the true relationship is complex. Whereas in non-parametric, do not fix the number of parameters in advance. Model complexity can grow with data. Example, KNN decision trees, kernel density estimation. Advantages: it is flexible and can fit complex patterns. Drawback: more data and computation, uh, and risk of overfitting. Now let's see supervised versus unsupervised learning. In supervised learning, it uses labeled data, input-output pairs. Goal is to learn mapping X to Y. Example, in supervised learning, there is an output data for every input, so that if a model, so that model learns from this pair, and if after learning and only input is passed, then the model generates output based on its learning. Example, classification of emails as spam/ham, regression to predict house prices, etc. Whereas in unsupervised learning, it uses only input data without labels. Goal is to discover structures such as cluster or latent representation. In this learning, there is no input-output pair. That model learns only from input, and its goal is to discover structure in that data and creates such clusters so that it can be easily represented. Example, K means clustering of customers, principal component analysis for dimensionality reduction. So now let's discuss B part for this question, which states that define accuracy, precision, recall, F1 score and illustrate their computation using a confusion matrix. So solution, this is the confusion matrix. In this, the first is true positive, true negative, false positive and false negative. So true positive, it predicted positive and actually positive. False positive is predicted positive but actually negative. True negative is predicted negative but actually negative. And false negative is predicted negative but actually positive. And its metrics are accuracy, in which true positive plus true negative divided by a whole, and precision is true positive divided by true positive plus false positive, and recall is true positive divided by true positive plus false negative, and F1 score is 2 times precision and recall divided by precision plus recall. Example, suppose TP is 40, false positive is 10, true negative is 30 and false negative is 20. So accuracy will be 40 plus 30 divided by 100, which is 0.7, and precision will be 0.8, recall will be approx 0.67, and F1 score will be approx 0.73. So this is it for question 5th. We'll be covering next question in another video. Thank you.